Hello, everyone. Thanks so much for joining today's webinar. We're just going to jump right into it. Today's talk is going to be about building microservice architectures in AWS. We hope to highlight some of the benefits and considerations before building a microservice architecture. We will also be providing some real-world success stories from 2 different customers. Before we begin, let me cover some logistics, though. During the presentation, feel free to ask questions in the section below the presentation. We'll have a Q&A section at the end of today's webinar, where we'll do our best to answer all of your questions. So welcome again, everyone. My name is Ryan Bachman, and I'm the Director of Technology here at Mission. I'm talking to you today from Raleigh, North Carolina. Just a little to share about myself. I am a passionate cloud architect. I really enjoy composing systems in the cloud for the cloud. I tend to gravitate towards event-driven frameworks powered on serverless technologies. I'm also a passionate home automation enthusiast. My favorite solution to date so far is my pressure plate integrated mattress that connects to my home coffee machine. So when I wake up in the morning and get out of bed, my coffee is brewed fresh. Last and probably most importantly, other than my family, is I'm an avid foodie and I've traveled the world just to eat. So if anyone has suggestions where I need to venture next or knows of an obscure bourbon or scotch I need to check out, drop me in a note in the feedback. That's probably more important than your questions. Just joking, but no, please let me know. I'm joined today by Nick from New Relic, and I'll let him introduce himself.
Thanks, Ryan. I definitely need to talk to you about the whiskeys and the coffee. In terms of my introduction, I'm a solution architect, a pre-sales architect at New Relic APJ, and I work with 2 types of customers here. So what we call as the digital migrants and the digital natives. So I've been fortunate enough to work with clients that have planet-scale applications and transactions. I live in Melbourne and support the type of companies I mentioned right from my house and sometimes from the city. In terms of my interests, I've been dabbling my feet with Node.js, K8. I have been doing a lot of Docker of late. And in terms of my experience, for the last 8+ years, I've been in the DevOps space. Talking of coffee, even I have a world-famous coffee. Out here in Melbourne, we're quite proud of our coffee, and I've got 1 cup in my hand right now. So I hope you have the same. So Ryan, passing it back to you.
Excellent. Thanks, Nick. First, we're going to talk a little bit about who Mission is. So we are a partner of Amazon. We are a premier consulting and managed cloud provider. We're based out of Los Angeles, and we also have an office in Boston. While we are a partner of Amazon, we also like to consider ourselves a partner to our customers, specifically businesses that are looking to take full advantage of Amazon Web Services. And we build this partnership across the full spectrum of your cloud journey, from architecture at the beginning of that journey, doing readiness assessments, helping build out technology roadmaps, assisting with helping build out POCs to prove out the adoption of AWS. We do migrations and cloud transformations, implement CI/CD pipelines, infrastructure as code. And then we also offer a full suite of 24/7 services, including monitoring and management of your environments. So if you're anxious to get rid of those late-night alerts and hand those to us, we'll be happy to take them from you. And finally, we also offer optimization services, really focused on optimizing your environment for efficiency and cost within AWS. I'm now going to hand it back over to Nick to introduce his organization.
Thanks, Ryan. So in terms of New Relic introduction, I think before introducing New Relic, you ought to understand the type of clients we work with and our prospects. So, there are a lot of companies who are now simplifying previously complex problems. And most of the times, in terms of solving that problems, they decide to go cloud. So cloud native services or hybrid cloud strategy to support their workloads. And eventually, they want to be able to build an accelerated feature delivery system. So what New Relic does for this type of client is we provide an observability platform. And the concepts behind observability, I think a lot of you might already know. But in order to support observability for these customers, we have built an open platform whereby you can instrument everything so that you have no blind spots, which means even if you want to send data into New Relic from your OSS systems or any other data source, you can use our open APIs. The second key capability is connected. So what we do in terms of that theme, we want to understand quickly and act more effectively. So we bring cross-stack insights, which I personally refer to as multi-dimensional monitoring. And then the third piece is, a lot of times, we have a certain level of understanding on what the clients want, but nobody understands the client's problem better than themselves. So what we have done is, in the latest installment of New Relic, we've also supported a programmable theme. So you will be able to build your unique applications that drive your business in terms of a UI app as well. And that is something which is possible with one.newrelic.com. So I'm going to forward it back to Ryan to talk about the agenda for the Presso.
Thanks for that great introduction of New Relic, Nick. Really appreciate that. So just to do a quick review of our agenda for today, we are first going to level set and come to a common understanding on what a microservice is. We are then going to unpack that a little and discuss the benefits and trade-offs of microservices. What are the challenges you may face when you adopt them and what they aim to solve? Nick is then going to lead us through a case study and a couple demonstrations. I will then talk about a mission customer and how we help solve some performance issues using microservices. We will also leave some time at the end for some Q&A and discuss any next steps. So before we begin talking about microservices in depth, we probably should define specifically what microservices are. So the word microservices is made up of two parts, the first being micro, which means small. And it's not just the size of the code itself that is intended to be small, but also small in the set of responsibilities, in the set of its dependencies, and the size of the team needed to support development of the service. And then what do we mean by a service? So a service is a set of functions or logic that provides a defined set of protocols, a defined contract, and hopefully defined SLAs. And as a consumer of that service, you can trust that the service will adhere to those definitions. And going a bit further, a better definition would be microservices are single-purpose, self-contained services with well-defined protocols and published SLAs designed to be built and operated by small autonomous teams. And when you take applications and you build out workloads from different microservices and you compose those microservices into an application using a series of interconnected and loosely coupled services, we call that a microservices architecture. And for a different perspective, let's look at a quote from Adrian Cockcroft, who is a VP at AWS on Cloud Architect Strategy. He's also a pioneer in the microservices space. So Adrian defines microservices architecture as a service-oriented architecture composed of loosely coupled elements that have bounded context. I really enjoy that definition because it says a lot with a few words. So let me try to break it down just a bit. So it starts with a service-oriented architecture, and that means we have multiple microservices that communicate with each other over the network. That will be a key point when we discuss the trade-offs in a little bit. But the notion is that we have many services connected together that are composed into loosely coupled elements. And that means that they are more or less autonomous and independent from each other. They can be updated separately, versioned differently, scaled with different policies. And what that results in is the ability to move faster in development, but it also means development teams can target optimizations to very specific sets of components that make up a whole application. And that independence you get with microservices is protected by a bounded context, which means they're completely self-contained. So if I'm working on a microservice, I have no need to know the inner workings of the other services I may need to integrate with to build out an application. And this creates a lot of freedom for me as a developer, because just as I don't need to know the details of other services, other microservices do not need to know the specific details of mine. And this allows me the freedom to implement my service in the way best suited for the task I'm trying to solve. It's the whole right tool for the right job mentality. And now let's talk a little bit about some key elements to consider in building out a modern microservices application. So one aspect to consider is how you deploy changes into your application's environment. This is one of the driving factors that has led to the increased demand for the adoption of DevOps principles. In order to manage the additional moving parts that come with a microservice deployment, automation is essential. So to really take full advantage of the agility and velocity that can come with a microservice architecture comes the need for that level of automation and repeatability so development teams can focus on the capabilities of the service and automation can do the repeatable tasks that sometimes slow teams down. Another key ingredient here is the concept of infrastructure as code, defining your resources, storing those definitions in some code repository, and implementing standard dev practices around how updates are made and how changes are reviewed are all good ideas. A microservices architecture should take advantage of the elasticity of the cloud. Since microservices are independent and generally smaller workloads, scaling policies based on the resources that the service consumes should be driving that scaling. So for instance, if I have a compute-intensive microservice that is doing a bunch of analytics or number crunching, as more jobs hit that service, I would expect to see, CPU usage increase. Services should have a mechanism that provide additional compute resources to handle that additional load. Concepts such as like auto-scaling groups for EC2 or launch configurations on ECS are great tools to consider here. And when building out microservice-based applications, you should also consider the cloud when decomposing the application. There are many managed cloud services that your application can integrate with that likely solve some of the challenges you face within your own application. The microservices you choose to develop and work on should really be the special sauce of what you're solving for, and lean on managed services to help offload some of the heavy lifting. Additional benefits of managed services include lower costs, proven technology, and overall less operational overhead. And I'll be introducing some examples from AWS in a couple slides. And you also have to think about orchestration. While it is related to automation, it considers the system as a whole. So just because each service is independent from one another doesn't necessarily mean that a series of codependent steps are not required for successful deployments when introducing new application features. So tools like Kubernetes are great for orchestrating container-based microservices. I've seen other organizations use Terraform, Ansible, Chef, the likes of those, to help build out their orchestration as well. And then finally, sitting underneath all of this is a need to consider how you are going to audit the environment. So this is maybe considered a drawback, but a drawback I would argue is worth it. So without the right tooling, it can be difficult to trace and debug in a distributed environment. In a monolith, your log files are typically in the same spot. Debugging is generally done in a very specific way. But in an environment that uses or user action traverses dozens of services, all in different languages, interconnected, by the network, and sometimes relying on cloud-native services. Unless you have the right observability tools in place, this task can potentially be a challenge. Later, we'll hear from Nick again from New Relic, and New Relic is Mission's go-to tool in solving for this challenge. So what are some of the main drivers for people to switch to microservices? Sure, there's a lot of peer pressure that happens in keeping up with the Joneses mentality, but I also think there are some major benefits in adopting a services-oriented architecture. First, it increases agility and velocity. It does this by granting that freedom I mentioned earlier. In monoliths, you often have to worry about how a change in one part of the code affects another part, but with microservices, the scope of responsibilities is much smaller. So you can build single-purpose teams around these microservices to help achieve a more flexible application. I also mentioned earlier you can scale different parts of the application in different ways. Before, you likely may have had to spin up additional new servers just to handle a very specific and infrequent function of your monolith. With microservices, you can be more deliberate on how and when to scale. Deployments are simplified in many ways, especially in the cloud. Deployment methods such as like blue-green or canary deployments are made simple. There are purpose-built tools and services that help you achieve zero or low interruption deployments when you're deploying microservices. And microservices also brings a lot of freedom. Teams can adopt their own patterns, frameworks, even languages. I once worked as a developer for a cloud-based call center company. Essentially, we were trying to migrate what we were previously building on specialized hardware to run completely as a SaaS application in AWS. I think when we went to production, we had something like over 60 microservices built on 10 different languages, about the same amount of database technologies, all interconnected by 3 or 4 different queuing or bus technologies. And some might consider that a lot of overhead or tech sprawl, but the way I look at that, it's giving teams and engineers and service owners the freedom to do what they feel is best. And then, like I mentioned a couple slides back, I want to introduce a couple of the AWS managed services that are also microservices themselves. So Aurora Serverless is a great service when building out an application that requires infrequent or unpredictable transactions, requiring a relational database. Amazon S3, I personally feel, can be used for just about anything in your application. So it's a blob storage based on keys. It has different storage classes that affect cost and availability SLAs. And you honestly can use it for persistent data, transient data, long-term, short-term, and also as like an integration point between two different systems. You really could get creative on how you use S3. An API gateway is AWS REST and WebSocket API solution. It's a serverless managed service. I love its flexibility in assigning different backend integrations and security settings, all the way down to the method type. All you need to do is define your API in a Swagger doc or the console or any other kind of provisioning tool. An API gateway will handle the rest. Amazon SNS is a pub/sub service that can push out messages via HTTP, email, mobile to help you integrate with third parties. Lex is a great service to consider when building voice-enabled or chat features within your application. And then finally, we have Amazon Kinesis, which is another kind of serverless technology used for ordered event processing. So it provides massive scaling capabilities for streaming data. And then in addition to Kinesis, Amazon released Managed Kafka last year, which would be considered kind of an alternative to Kinesis. So with all that said, let's shift gears over to our partner New Relic to discuss a case study where they help a customer leverage microservices.
Brilliant. That was really insightful, Ryan. Thanks for that. In fact, for my demo application, I'm using some of the services that you just shared, right? So I think we're going to have a lot of fun. So this part of the presentation is a subset of my AWS reInvent Presso in November last year. And I've also got another definition of microservices for the audience today. So let's look at it this way. Take a single big problem and spread it around so that it's difficult to find them. That's how one of my clients define microservices. And in this particular case study, you know, the customer and their challenges and their ecosystem is no different. So it's microservices native. I would like to introduce Fleet Complete, who is using all the building blocks that Ryan introduced from the microservices diagram and the underlying building blocks from AWS-specific services as well. So essentially, they are an IoT business with a large car fleet for corporate and individual clients. More specifically, they are a GPS fleet management software and solutions that are tailored to a lot of other companies' unique needs. So the way I understand their technology, they have a lot of intelligence built on their car fleet via an IoT endpoint. And this endpoint reports into their analytics mothership and their data tier services and makes a lot of manual jobs like start trip, stop trip, automated machine intelligence related analytics is collected through that stack as well. And it's in Fleet Complete language, they're trying to do three things through the microservices program. So they want to offer their products and services in the marketplace. And secondly, they want to make these services and products profitable. And lastly, they want to make sure that the user experience for these services is error-free. So this is where New Relic comes into the picture to allow them with faster speed to the market and to allow them to debug production incidents. And when you look at it from an engineering perspective, we want to be able to allow them to develop and debug iteratively. And that means you ought to be able to provide a common shared insights platform and language to all the team members. Sometimes we're looking at thousands of technologists and executives in case of some of our bigger clients. So how have we done this? We basically built an extensive set of partnerships with companies like Mission Cloud, with the cloud companies, Terraform, OSS services, tons of SIs and delivery partners. So as a part of this portion of the webinar, I also want to introduce to you, in case you are new to this microservices world and development of modern microservices, why would you even consider building one? So aside some of the attributes that were covered off by Ryan, there are a lot of operational benefits. So think this way: if you want to build and iterate a service rather quickly, microservices built atop AWS provides you the least burden of operation. Second, there is cost efficiency because there is a no traffic, no cost principle in place as well. And then it also allows you to leverage the abstracted services, in this case, managed Kubernetes, your Lambda services and Fargate. So this is the rationale Fleet Complete found for building their own sets of microservices. Now, if we go into the demonstration related use case, so I built this application, which I refer to as human space migration application. So the theme we had was pretty simple. Imagine we have 11 viewers on this webinar right now, and there will be a lot of on-demand viewers later once we post it on the website. Imagine you are the candidate who will be able to register their votes because the Earth is no longer habitable. And as a part of supporting this program, we had to quickly come up with a front end, which is obviously internet-facing, where users can register themselves. They can pick one destination or the other. So in this case, fictitiously, it's either Mars or Jupiter. And then you get to also send your last wishes to fellow humans who are not yet registered or able to go. So that's the theme here. And the architecture we use is pretty simple. So there is a Node.js front end supported on a Kubernetes service, which talks to a queuing service, which in this case is a UI queuing service, which in turn forwards the request to a Lambda parser. The Lambda parser then talks to the parser queue, and the parser queue has two routes. One is to the Lambda worker that will either send any user request for persistence and storage purposes, or it might also connect to Fargate for analytics purposes. So that's the environment we have here. And all the basic microservices principles, they apply here as well, auto scaling, DevOps pipeline, cloud native services, and a bedrock of observability. So let's see a little bit of a demo. So I'm going to do a screen share, and I'm hoping you'll be able to see me as well, so that Ryan and I, we are real people. So let me share my screen here. Okay, just give it a few seconds. So this is the application, and I now want you to engage with this application. So I've got a QR code. So if you pull out your phones and point the camera at this application, you would be able to interact with the application as well. So I'm going to do the same as you are pointing your phones to the QR code. There was a really funny scenario. There was a security tester amongst us during the AWS reInvent session. And he had decided, he was determined to bring down the website. So he was sending in a lot of garbage. He used all the potential tools to attack the website and bring it down. And I was able to capture all the user activity while respecting the user confidentiality and the PIIs. So I requested to meet him after the session, and he gladly did so. So luckily, because of the way AWS manages your application, he wasn't able to bring it down. But I'm open to challenge. I would let you try to do the same. So this is what you should be seeing. And if you go to this section where you can send your last wishes to fellow citizens, I will then show you a demo based on the real data that is coming through. So let's say if I send in hi webinar folks, it will then go through that full architecture and beam back the last message. And in the background, I also have load testing and automation running in place as well. So how did I enable all this application? I essentially used the best-in-class AWS principles. So I have a CloudFormation stack for each type of service that I shared in the architecture. And here, if you click on one sample service, you can see that the output and the resources set up here is everything you can imagine. So things like the Lambda function, the parser queue, the actual roles, the DynamoDB table, and whatnot. And for the Kubernetes services, you can see the EKS service being set up. So if I wanted to make a change, I would simply update my CloudFormation stack and update it that way. And the second thing I wanted to share with you here is if I'm to emulate the messaging service, I can click on my queue, my front-end queue. So I can emulate that send message transaction, and I can say, hi, webinar. And when I send this, it would be able to use that full chain of services, which is quite complex, to be truthful. You then click on DynamoDB, where everything gets stored in terms of a database. So if I click on DynamoDB and I look at the latest table entries, I will be able to look for my specific table and then simply say items and do a refresh. So these are all the messages I've been able to collate so far. So that goes to show that my application is functional. Now I want to stop sharing at this stage, and hopefully I was able to give you a sneak peek into how these services are best built, but I want to hit it home with some key takeaway points. So those key takeaway points are modern AWS services allow you for the least possible operational burden. And secondly, leverage cloud formation templates because they are easy and they allow you to automate the deployment of resources. So really following infrastructure as a code methodology. And lastly, because a lot of companies are new to cloud and developers and the engineering teams don't necessarily follow a strict routine of reclaiming wastage compute resources, you want to be able to understand cost containment scenarios, and specifically for the Kubernetes services, you might want to look at cost from a namespace angle, from a namespace perspective. So I will show you in my second demo how that is possible, but hopefully all of these key takeaways made sense for the audience. Now, this brings us to the second demonstration here, which I have prepared for you. So let me share my screen one more time. So this time around, based on the data load testing service, and based on that initial application that I showed you, I now want to showcase to you how you can leverage this data and run a really robust engineering team. So the idea here is pretty simple. Reduce the total number of bugs before your service and its features are rolled out in production. Then reduce the number of incidents in terms of your S1, S2, or P1, P2s in your production environment, and also enable a common data platform for shared insights across engineering and executives. So let's dive into the second piece of demonstration here. And this time around, I'm going to share with you a view of New Relic homepage. So this is onenewrelic.com, and it offers those three themes, open, connected, and programmable. So up at the top, you see all the programmable apps that are made available on developer.newrelic.com and some default apps. So these entity explorers allow you to look at every single service, database, infrastructure, host. Doesn't matter what you are looking at, as long as you have a monitoring agent in place, it will organize that entity you are observing under this particular app. It also allows you cross-service communication flow, which we refer to as distributed tracing. I like to think of this as a CCTV for your service-to-service communication. So all the batch transactions are detected in terms of traces under this particular UI. And similarly, you have some detailed UI to look at your backend applications or microservices, at your Kubernetes services, and you can also define workloads. So here, this workload is a collection of your applications that you are most concerned with. And I will show you shortly what that looks like. On the right-hand side, you got alert patterns, which are now pointing out that one of the applications are misbehaving. So if you click on it, it will take you straight to that news bulletin type of insight, whereby you can understand which application. So here you can see the application is Origami CMS. So I'm going to show you three critical screens that you could use in your production day-to-day SRE practices or within your DevOps team. So this is a workload which I have defined, and the workload is made up of that same infrastructure that I shared with you. And here, cut to the chase, I'm being told 2 of my hosts are misbehaving and 3 of my services are misbehaving out of all these different pieces of entities, monitored entities that make up my space migration application or any other application that you might be supporting today. And you also see shipping service, fulfillment service, they are all violating different conditions. So this is literally define your environment within New Relic, and it will create an automated single pane of glass and a traffic light service status for each and every entity that you group together. So this in action, you can click on, and it will take you into a microscopic view of the entity that you clicked on. So here it's a particular host that has anomalies in place, and New Relic alerting engine is automatically highlighting the time when that anomaly started and the time up until that anomaly lasted. So I want to also showcase to you a cloud optimized use case. A lot of companies, as I was saying, are going cloud native, and there are tons of opportunities to optimize workloads on cloud and reclaim wasted compute. So here we have one of our UI apps that you can deploy from developer.newrelic.com, and it is free to use. So here, let's say I want to look at it from a Kubernetes cluster perspective. I click on my Kubernetes cluster, and it shows me all the cluster nodes, the worker nodes, and the allocated instance type, the maximum CPU percentage consumed, the max memory consumed, and other important SLIs. And it makes recommendations that you are currently over-provisioned, and you might want to think about downsizing, and that will result in tons of dollar savings for your company. You can export this report and share with your cloud team, and that way they can start the program. A lot of our clients here in APJ, and one client particularly I worked with who are a telco company, they were able to unlock 7-figure dollar savings using this free cloud optimization app on New Relic. And if all of that made sense, do ask us more specific questions later during the Q&A session. But the last thing I want to show you here is how we have built cloud-native performance management UI. So here we have a 3D diagram, which organically leads you into problems. So the center concentric ring shows you the most grave problems. The second ring shows you caution level problems, and the outermost ring shows you the nodes and the underlying pods. So if I want to quickly get down to business and debug issues that might be stopping my clients from, completing transactions and helping us generate revenue, you can go to this event view. You can filter warning only. You can then click on a particular pod, which on the right-hand side will open up a pane. And that pane is going to show you that pod, the reason for the warning. So here you can immediately see that the tag you had in your Docker file and your Kubernetes deployment was erroneous, and that's why there is an issue. So similarly, if you click on another pod, you might be able to go down from a pod level into container level, and here this container failed. So if you want to see the logs on why this container failed, you can then click on the log viewer, and in context, that connected theme of New Relic, it's going to show you why that container failed. So this is pretty powerful because you go from a telescopic view into microscopic view at a click of a button, and you're able to save your production incidents and your customer experience via these simple restricted workflows that naturally guide you into problems. So I'll stop there, and I will now stop the demonstration. And before I pass it back to Ryan, I'm going to summarize the key takeaways from this little case study that we presented. So here the key takeaways are leverage easy-to-use wizards and tools for full observability. So, the UIs we have put in place, the native event collection, and the logs monitoring that we have enabled to provide you deep dive modern microservices management. Secondly, codify your monitoring and monitor your code pipeline to be able to gamify your engineering and make your engineering teams and your engineering factory an exciting one. And thirdly, keep the compute lean and keep the planet green. We all understand, we need to treat the planet a bit better. I think if you start optimizing your cloud workloads today, that's one way to do it. And I don't mean it in a tongue-in-cheek way. So I'm going to conclude this part of the presentation and pass the control back to my peer, Ryan. Ryan, over to you.
Thanks, Nick. I almost want to take on your challenge. So if you can leave the app up for the rest of the day, I'll see what I can do. I also want to call out if anyone on the call is, oh, nice, thank you. If anyone on the call is interested in any of those amazing New Relic capabilities demonstrated by Nick, please reach out at Mission, and we can set up a call and discuss where we can assist. And I'll share how to contact us at the end of this webinar. So we're now going to focus on a Mission customer, Your Call Football. So Your Call Football is a really unique mobile gaming platform / interactive reality. It incorporates real-life football with fantasy-style fan-source game calling. So how it works is a real coach on the sideline would call a play package that is then sent to a mobile application where users would get to vote on a choice of a few specific plays. So almost think, I don't know if there's any John Madden game fans, but think of like John Madden. And that play call with the most user votes would be relayed back to the coaching staff, then to the players on the field. And you score points by having voted for the chosen play call and whether or not that play was successful. So it's kind of a real innovative way to allow people to be virtual football coaches, but instead of a video game dictating results, you have real football players following your game plan. And it was anticipated that a large number of concurrent users would be on the application at a given time. And due to the nature of the game relying on an actual live sport, no delays in the voting aspect could be afforded, or the relay back to the sideline. And their developers had already developed the majority of the application capabilities in a single monolith, but they needed help with scaling the application, meeting identified response times, and the overall operational aspect of managing your application in order to maintain the level of performance that they were, wanting to provide their customers. And these challenges were too many for their team, so they reached out to Mission for help. So we started with their single monolith that met all the functional requirements, but lacked the ability to meet performance specs and had several identified bottlenecks. The goal of the project was to decompose the monolith into domain-specific microservices to be run on Kubernetes clusters in order to deliver the necessary performance and meet the anticipated demand. There was also a tight timeline to deliver these results. These live games had already been scheduled at the participating venues, so Mission had to deliver a working solution prior to kickoff. So as you can imagine, the previous architecture suffered from several single points of failure. Mission incorporated high availability or failover for all microservices and also took advantage of AWS managed services where able. The previous environment was also not able to scale in either direction to meet the customer demand while still considering overall cost. So to overcome this behavior, Mission replaced the monolith built on an EC2 cluster with microservices run on Kubernetes with an Elasticsearch Redis layer. After some performance tuning, we were able to meet game time performance requirements and only had to scale an hour in advance of the games. And lastly, the management at your call wanted to enable their developers the ability to deploy and update code as well as scale the system when needed, but they also wanted the developers out of the AWS console. So we worked with them and built an automated deployment pipeline using tools like Terraform and Jenkins. And this allowed developers to focus on the code rather than the mechanics of the deployments and ultimately made them more productive. Additionally, the automated pipeline made sure that security and governance policies remain compliant. So this is a high-level diagram of what we built. We built the networking clusters, databases, the other AWS components using Terraform so that we could quickly make changes and scale their environment up when needed, while also ensuring uniformity across environments such as staging and QA. We used Aurora RDS for storing user data and other information, but the majority of the in-game stats and session information was stored in Redis, in Elasticache, and the queues. And in order to isolate the loads, we built multiple clusters and tuned in on the ideal pod density for each to squeeze out some additional performance gains. And then for season one of this application, we actually deployed those Kubernetes clusters on EC2 since EKS was not GA yet. But for the most recent season, we migrated to a single ECS control plane cluster with worker node groups. This actually resulted in better performance after the migration in terms of scaling time, while also reducing management overhead for everyone involved. And we are now looking at additional migrations, probably to Lambda or Fargate for additional benefits in both the performance metrics and cost, as well as making sure we account for these new technologies and the CI/CD pipelines that we originally built. And the optimizations that Mission led is really enabling the customer to provide thousands of football fans a fun and unique, but also issue-free gaming experience, all in real time. So that concludes the content portion of today's presentation. So I'm going to turn it back over to Nick, and he's going to address some common questions that he frequently receives.
Absolutely. Thanks for that, Ryan. So, we get asked a lot of these common questions during such webinars. So what we wanted to do here is, answer some of these questions for you. And at the same time, we want to motivate you to ask specific questions that you might have. So there is an option available on the webinar link to be able to ask those questions. But in terms of the first question here, this is something that we keep hearing from our clients. If you are already midway in your cloud journey and you are refactoring applications or migrating them over to AWS, what phase is Mission able to support you? So the response to that question is, regardless of where you are in your cloud journey, if you need consulting around architecture, migration, and optimization of your workloads, you can engage us at at any stage, really. The second question I've got here is, our SREs and DevOps teams are struggling to deliver a highly scalable and nimble service. Can you help here? So this is right up our alley in terms of delivering. The core use cases that we solve, Mission and New Relic together, is for these type of highly scalable and nimble services. We not only help you in terms of setting up your alerting and dashboarding strategy and building an automated pipeline. We typically treat any team on a persona basis, and we strongly follow a jobs to be done framework. So we interview the team members, we ask them, what's their day-to-day KPI that they need to deliver, and essentially we build a simple workflow atop our solutions to be able to allow them to drive those workflows efficiently. So hopefully that made sense. The third question I've got here is, we have an existing cloud migration program for which we need expert services. How do we get started? So in a short while, we will provide you the details on how you can connect with the mission team. So just wait for that bit. And if this is something that you desire, feel free to reach out to us. Now, the next part is, we have hands-on training and enablement needs. Can you help here? So I am really strongly opinionated for enablement and training. I think every project has 3 phases, right? So the first phase is instrumentation or deployment. You can also call it activation, and activation of your key patterns. It could be, ensuring that you have the right visibility for your services and the right SLO tracking pattern in place, aka your alerting strategy. You could be using PagerDuty, Slack for different tiers of incidents. The most important piece that comes into that journey is the training and enablement need. And this is where we run New Relic University programs collaboratively with mission team, and we can assist you with any hands-on training and enablement needs within your company or within your teams. You can simply nominate the people who would benefit most from the training, and we basically organize the date for the training itself. Now, the next question is a rather intriguing one. Our observability strategy is weak. How can you help here? I think a lot of times companies in their inception and startup stage, or if they're building a brand new service in that launch phase for that service, they don't run into observability problems. But as soon as stability hits their services, they end up pumping the brakes on their innovation engine, and they start, sending all the resourcing into monitoring and management of the service. So that I feel is a knee-jerk reaction that shouldn't be in place for most companies. A better way to approach is start by building the guiding principles, having the right team architecture. And then once you have the team architecture in place, embrace concepts like chaos testing, code pipeline, and automation, and even observability right through the life cycle of a service. So we can help you with either of those programs, and particularly the last one. We regularly work with clients who have a weak observability strategy and who require specialist knowledge. And we have a ready-to-go template for these type of strategy conversations. So we'll be super keen on chatting with you around this. I think for cloud-native workloads, it really depends on what type of help you need with those workloads. So it will be a subjective response, but a common one is embracing the least operational burden driving services like Lambda, managed Kubernetes, Fargate. And if you are mostly living in the EC2 world today and you want to migrate over to those more cutting-edge services, I think that's a very common conversation we can help you with. I think the last point here we got is how do you engage Mission Cloud in New Relic? And for that, I'm going to bring on board this slide with the details on how you can get in touch with us. But at this point in time, if you have any questions, feel free to send them through using the webinar link that you have.
Sorry about that. Yeah, we got competing. Sorry about that, Nick.
No, all good.
All right. Yes.
Ryan, I was going to pass it back to you.
Okay. Thanks, Nick, for answering those frequently asked questions. Like Nick mentioned, if you are at all interested in anything you hear today, whether that be New Relic or building microservices or anything else involved in your cloud journey or your needs as a company or organization, please feel free to reach out to Mission. We are experts on New Relic and the platform that Nick showed, and also building in AWS. So here's our contact. You can reach us via email at sales@missioncloud.com, and we left a 1-800 or I guess 855 toll-free number for you to contact as well. And please, if there are any questions on the content of today's webinar, anything top of mind, that scotch and whiskey or food that I brought up earlier, if you have anything, we're here until the top of the hour to address any of your needs. And I'll leave this contact information up for a bit, just so you have it.
Fantastic. So Ryan, I don't think there are questions from the audience end. I guess
okay.
we can terminate the webinar, and I know we're going to share the link to the recording itself, and I guess we can close it here. It's up to you.
Yeah, no, that sounds good. If there's no questions, and I don't see any questions from the audience, we really appreciate your time. Hopefully, you were able to take something away from today's presentation, and we look forward to engaging you guys in the future. All right. Thanks, everyone. Have a wonderful rest of your day. Thanks.
Fantastic.